Good morning, good afternoon, good evening to you wherever you are joining us from. Thank you for joining me for this fifth session of CICD Summer School. The label for this session is 4 because we started counting from 0. I'm your host, Michael Jenkins. I'm a LinkedIn learning author, and I produce content on subjects like CICD, software development, and all things cloud. I just really do appreciate having the experience in this particular industry and being able to share my thoughts and knowledge with you. So, thanks again for joining me today. Um, and we always do a shout out at the beginning of these sessions. So if you're joining us live or if you're watching the replay, thanks to you all as well. Drop into the chat where you're joining us from. I will say I'm joining you from beautiful Southern California, just outside of Los Angeles. The image that you see behind me is the Manhattan Beach Pier. Yeah, and that's like not too far away from me. So that's one of the beaches that I enjoy going to when I'm hanging out here in Southern California. Um, let's get right into the next session of this, or the next portion of this, which is let me see, make sure, around the way. Subjects or resources from around the way. These are resources that I tap into to hone my skills, um, content creators that I follow, podcasts that I listen to, and other resources that I find beneficial. And I hope that you will as well. So let's get right into it. Um, I wanted to share with you this week the Platform Engineering Podcast. It's another technology podcast that I listen to from time to time. And in this particular case, they are having a special series called Foundations of the Cloud. And in this series, they're interviewing people that are or that were at the beginning of some of the fundamental technologies or software that we're using today in our work. You see on the screen there, you got Brian Grant, who is close to Kubernetes and its foundation, Mitchell Hashimoto, the founder of HashiCorp and the creator of Terraform, Vagrant, Nomad, and other software that we use. And then Adam Jacob, one of the founders of Chef, which is like one of the software that I really enjoyed using for configuration management. And what I appreciate about these particular series or these types of interviews is when we get to hear from these creators and sort of we learn the seed, like the cause that pushed them to create the software or create the technology that they finally brought to fruition. And I think it's important for us as technologists and as automators to know the history behind some of the tools or frameworks or software that we're using, so that as we see new problems arise, we know, number one, the tools that we can turn to, but also we can avoid some of the pitfalls or problems that these creators did many years ago. And I think it's also cool just for folks that maybe they don't understand some of the what I want to say, like the places that we came from as technologists who knew what the internet was like or knew what the cloud was like before it was the cloud, when you actually had to order computers and wait for them to come to your house before you can like put them into a rack, or or come to your office, put them into a rack, or take them to the data center, wire them up and make sure that the VLANs are correct and everything. These days you just go to the web, you log into AWS, GCP, Azure, and you click a button and you got servers, you got networks, you got databases, everything. We didn't always have that. So anyway, I appreciate listening to technologists like this describe their paths that led them to create the software that they created, and just to see how far we've come with the technology that we have available to us today. So check out the Platform Engineering Podcast and their series, Foundations of the Cloud. All right. Next up is it's just a Wikipedia page, but it's kind of fun for me. This is a comparison of web server software. Now, I have I don't know, it's like an addiction to web servers or an affinity to web servers. But in my career, I've worked with media companies that stream content or serve web pages at a high traffic scale, and so I was always interested in the software that actually enabled us to serve the content that we served. Starting out years and years ago, one of the first web servers I got a chance to work with was Apache, and it's definitely on this list here. After that, Nginx, but then I wanted to know like what other options were out there, and then I started to learn about Apache Tomcat, Jetty, which is more of an internal or like system to system web server, Caddy, which gives you a lot of security benefits, and just all these other web servers that were available. So this list was very helpful for me in just exploring and finding web server software that I could play around with. One of the ways that I use this list to actually hone my skills is to build software. So a lot of these web servers, they are provided as, or you can get the source. If they're open source, you can have access to either a tarball of the source code, or you can get to the repository where it's stored, whether it's on GitHub or Bitbucket or GitLab or wherever the case may be. If it's Apache, it might be on Subversion somewhere, who knows. But you can get the code and you can read the instructions to compile the code. And what I like to do with these different web servers is to see if I can compile it for like either my local target, like my laptop, which could be Windows, it could be Mac OS, could be Linux, or some other funky target, like I don't know, maybe a Raspberry Pi. Like, can I get this server running on compiled and running on a Raspberry Pi? Usually the instructions are there, and you can run the commands and everything, but you probably have to make some changes. You have to configure the system with specific libraries or new packages or whatever the case may be to compile this software. So that just kind of helps me hone my skill as an automator to know like, okay, what would it take to build this package if I was in a production scenario? I took it a step further with one of these projects, and actually, I should have had this as an around the way page here. But one of the web servers that I took an affinity to was the Cherokee web server. It's like this cool little C language based web server that did not have a Docker image, at least not one that I could find. So my goal with that particular web server was to build a Docker image so I could run it easily on my Mac OS system. So I basically learned how to build this web server from source code, package it into a container image, and then run the container. So that was just like a lot of fun for me to experiment with that particular web server. So anyway, I provide this as a source for you. If you got some projects that you're thinking about, you want to learn how to use some CI/CD software or just play around with some really cool tech, check out this list of web server software. Read, and this page also has histories behind the development of these particular applications. Just browse it a little bit, and if you find one that looks interesting to you, take a look at the code, see what it would take to build it, and then see if you can build it for your system. All right, let's get into what happened last week at CI/CD Summer School. Our topic last week was deployment methods for every scale, and we talked about the all-at-once approach, rolling deployments, and we even got into blue-green deployments. And we covered like which the speed of these, um, which ones would be safer to roll back, and maybe even the scale that we might use for each of these approaches. And then we also had some homework too. One assignment was to check out Canary Deployment, to do some research on your own about Canary deployments, and then to think about the deployment methods that you're using today. If you look at the projects that you're working on or thinking about working on, what types of deployment approaches are you using? And after considering that, I asked you to think about a different method that you might use instead, if it was even applicable to the situation that you were working with. And then following that, I wanted you to consider how can those deployment methods be combined. There was a repository for this particular assignment that just gave some additional information on these deployment methods. There wasn't any code associated with this particular homework assignment. It was just more of a thought process to get you kind of going in your own little research and development. But because we did not cover Canary deployments last time, and there was a lot of interest in Canary deployments, in this session, we're going to get a little bit closer with Canary deployments. So let's jump right into the meat of session 4, a closer look at Canary deployments. First of all, you might be wondering, why Canary, right? So we should probably, as we talked about in the Around the Way segment, the history behind this term Canary. Like when we look at rolling, all at once and blue green, we can kind of figure out from the name itself what these types of deployments are based on, right? All at once, boom, you get it all at once. Rolling, you're going to do it rolling one at a time. Blue green, you got something that's blue, you got something that's green, and you're going to switch between the two, right? But canary, that's a bird. So like, how does that come into play when we're talking about deployments? Well, let's talk about that history a little bit. So the term canary comes from I guess a technique, an approach that miners used in the past to protect themselves. So as these miners would go into these tunnels, there's the mines, the caves, wherever they were working, they could be exposed to gases. They could be exposed to the potential of the mine itself caving in around them, or whatever. Like all these sort of dangers that miners face. And so what they would do is they would take canaries with them in a little cage. And the reason being is that the canaries were more sensitive to these small changes in the environment. So if there was even just a little bit of gas that could harm a human, that little bit of a trace element might not harm us right away. But if we stayed in that element long enough, then it would may harm the miner. So, but the bird being a smaller organism, just a little bit of gas, it's going to be nervous, like, hey, something is going wrong. It's going to start flapping around in its cage, going crazy. And the miners know, like, hey, that's an early warning signal for us. Like, hey, we need to check out to see what's going on, to see, if there's a problem happening, or maybe we need to even leave, get the heck out of this mine, so that we can, be safe. So that's what the term canary really refers to, this small animal that miners would take with them in the caves to kind of give them an early warning if something was going wrong. So now we use the term canary to refer to our deployments, to our servers. We're going to take a small subset of the infrastructure that we're running, and we're going to test it out. We're going to apply some traffic to it. Not the entire load of what an application might be experiencing, but just a little portion of it. And we're going to see how the system responds. If it starts squawking and flapping its wings, as a server, may do in whatever form or fashion, maybe error logs or bad responses, then we're going to say, hey, something's wrong here, and we need to do something different. In our case, we're not getting the heck out of the mine. We're rolling back to a new version, or we're switching the traffic back over to servers that can actually handle this particular problem until we can fix the situation and then proceed with the deployment. So with that bit of history, let's get into the steps that it takes to implement a Canary deployment. In our last session, we used some of these particular icons to represent a deployment workflow. So we've got our trusty DevOps team and the integration and delivery pipelines that they use to produce an artifact, which is our software or application that we're deploying to our infrastructure. Then we have the artifact itself. It could be blue if it's the current version. It could be green if it's the newer version. And then also we have these cubes, which represent the compute of the infrastructure that's running our application. So if it's blue, it's running the current version. If it's green, it's new. It's what we just deployed. Then we also have this concept of a traffic controller. I'm calling it a traffic controller this time because that'll come into play specifically with this Canary deployment. Last week, I called it a load balancer, which still applies because load balancers, they control the traffic across, whatever compute is available to the targets that the load balancer is serving. But in this case, I'm calling it a traffic controller because we're going to be much more specific about the route that the traffic is taking based on the state of the Canary deployment. And with that in mind, we also need this new icon here, this traffic measurement, to show how much traffic we're sending in one particular direction, if it's blue or if it's green. And you'll see how this all comes to play here in just a minute, I promise. But I just wanted to kind of review that again if you didn't join us last session, or just as a reminder if you did. So let's jump right into this, starting with Canary Step 0. Now, if you did join last session, or you reviewed the lecture from last CICD summer school session, this looks probably kind of familiar, right? This looks a lot like the start of a blue-green deployment. We've got our cluster of compute that's serving 100% of the traffic, and we've got this other cluster that's not online. Maybe it's not even there right now, but it's a resource that we can tap into as a part of this deployment. So this is our state 0, where we've got our current version is deployed, everybody's happy, 100% of the traffic's routed to it, and we're ready to deploy something new. So in the next step, our trusty DevOps team, I mean, these guys are killing it, right? Because they are turning software around just as fast as we can click next on the keyboard. So thank you, DevOps team. We appreciate you for all the work that you do for getting the software ready for this particular discussion. They produced the artifact, so now we have something to deploy. So in the next step, we bring our compute online. Now we've got our green cluster available, and we're deploying this artifact to the green cluster. Take a look at the traffic. We're still sitting at 100% routing to the blue. And again, this looks a lot like a blue-green deployment. Nothing has really changed from the blue-green approach, right? So everything's still pretty much the same. No traffic is routing to our green cluster yet. All right. So now this is where things start to change a little bit. In this stage of a blue-green deployment, we would have just been looking at our cluster to make sure everything is okay before cutting over 100% to the green cluster. But because we're using a Canary approach, we're modifying our traffic controller, which could be a load balancer, it could be some other mechanism in our infrastructure, in such a way that 10% or just a little bit of the traffic gets routed over to the green cluster. And we're still going to monitor it. We're going to take a look at it. We haven't done a 100% cutover yet, because we want to say, hey, okay, can this new version of the software, does it work? Is it meeting our expectations? Is everything good? Did we have any bugs or anything? Did we miss anything? And we could check it out with just a portion of the traffic. So we're not affecting the entire user base or the entire amount of services that might be depending on this service being up and running. We're only taking a look at just a little bit of that traffic. So the impact of this particular deployment at this point is very small. If we needed to roll back at this point, then we could turn the knob in our traffic controller in such a way that 10% of the traffic goes back to 0 and 90 goes up to 100, so that we route the traffic back. So we have a little bit more control with whatever mechanism we're using to route the traffic from one cluster to the other. So that is pretty much where the Canary deployment really starts to kick in and lets us, use this little bird, and maybe I should have made them yellow, of a compute cluster and the traffic that's coming to it to test things out to see, okay, is this deployment really safe? And if it is, then we can proceed. So from here, we're still using our traffic controller. Nothing more has changed, but we're using our traffic controller to dial up the traffic to the green cluster. So you see in this graph, the blue cluster is now receiving 10% less traffic, and the green cluster is receiving 10% more traffic. So we just kind of dialed the gauge up another 10% on the green, dialed it down 10% on the blue. So the steps, we've been counting the steps as we go through here, just so we can kind of reference them and go back to them. I'm calling this step 4, and we're going to go up to some number n. Now that number n is a function of the percent increase. So in this case, if we're dialing down 10% every click, it's going to take us 10 steps, or from this 4 up to however many it takes to get down to the point where we have 100% of the traffic going to green and 0% of the traffic going to blue. We don't have to use 10% though. We could use 20% on each increment. We could use 30% on increment and then get to some funky state where you have just a little bit. We could do 5% to start and then jack it up another 10 and then go all the way up to 100% because we're confident in the infrastructure. So we've got some flexibility there in the amount of traffic that we're sending over. But again, that's all going to be dependent on the application. It's going to be dependent on our traffic controller and the amount of control that we have on it. And, we'll use those things as sort of the knobs to control how long this deployment will take in terms of routing the traffic from the blue to the green. Okay, but we do get to some state that I'm just calling this Canary in because we've routed all the traffic over from the blue to the green. So now we've got 100% going there. Everybody's happy. Everything looks good. The DevOps team, they're probably going to happy hour to celebrate. It's another, successful deployment, and everything is good. But if you remember from the blue-green deployment from last session, we still got a little bit of work to do, right? We got to decommission that blue server or do something with it because we don't want to have servers or compute just sitting around doing nothing and running up our cloud bill, right? So we can decommission those servers, get them out of the way, and definitely no traffic, 0% traffic is going over there in this particular case. Or, we could keep them online if we can afford it and just have them ready and waiting for the next deployment. So we've got some options there as well. But that pretty much wraps up the discussion on Canary deployments. That's pretty much all there is to it. So let's take a look at some of these points that we were using to grade or consider this deployment. The speed of the deployment, it kind of depends, right? It depends on a couple things. One, the amount of traffic that we change in each shift. So if it, like I mentioned earlier, if we're only doing 10% per click, 10% per iteration, then it's going to take 10 times, the amount of time it takes to route the traffic over. But then also we have to add to that the amount of time that we hold at that particular percentage, right? So we've got the percentage that we're cutting over and the amount of time that we allow that percentage to route. So those two things all kind of play into how long our Canary deployment takes. So it kind of depends. You have to look at your application, your infrastructure, and figure out the best approach for, making sure that your deployment completes in a proper amount of time. The rollback is pretty safe, right? Because similar to the blue-green approach, we still have this blue cluster that's serving the code, or rather serving the software, and we can roll back to it pretty much at a moment's notice, right? We may have to do something funky with this traffic controller to make sure that we're dialing back at a rate that doesn't sort of overwhelm things. But we know that we can get back to a known state relatively easy with this approach because it's sort of like an overlay on the blue-green approach, and we know how that works. For the scale is pretty much unlimited, right? Like if we wanted to use this approach to an application that was deployed across regions or compute that was just a couple different servers, This would be a viable approach. Now, the larger scale that you get, though, you have to consider the cost because, similar to a blue green, you have twice the infrastructure or maybe more of the infrastructure than you would normally have to run the application. And I say more because sometimes you can use a different approach with Canary approach in that compute cluster, the green compute cluster might be smaller. It might not be the exact same size. And we'll take a look at an example of that here in just a bit. But if we're going at the or using the approach where we're following the blue green method, then we're pretty much going to double our costs for some period of time. It's not going to be forever. It's going to be some period of time. So we definitely have to keep that in mind as well. Okay, one of the things that was a homework assignment from last week was to consider combining deployment methods. All at once, you definitely one that you can combine with these other methods, but I wanted to consider rolling, blue, green, and canary for the way that some of these deployment methods are combined. And one example that I found was from an article called Canary Releases by Danilo Santos, who is a very distinguished engineer at ThoughtWorks. This is from a paper he wrote some time ago that demonstrated deployments at Facebook. So I want to just take a look at this for a moment and see if you can find deployment methods or different deployment methods and how they're combined in this particular deployment. But let's just kind of talk about this for a little bit. It looks like we have 3 clusters of compute. We have one cluster, looks like it's serving Facebook employees only. That's labeled as A1. We have 2 other clusters, A2 and A3, that are serving Facebook users. And we've got very similar to the diagrams that we've seen earlier, this traffic controller that's between the users and these clusters, and it's routing the traffic between the 2 of them. Now we can just look at visually at this diagram and see that cluster A2 is smaller, has fewer compute resources in it than the A3 cluster, which has a whole bunch more, right? And we also see this package that's coming in from the left, again, very similar to some of the diagrams that we've seen throughout this discussion, and how it's moving across these different clusters, starting in A1, going to A2, going to A3. So just kind of visualizing or just kind of talking out, verbalizing this diagram, I can spot a couple, maybe a few different deployment methods in this particular description. I'm curious to see what you're thinking. Yeah, but let's go right into the solution here. I definitely see a rolling deployment. This big arrow across the bottom and the compute clusters, we're seeing a rolling deployment that's starting at A1, is being validated or verified or whatever the case is, moving to A2, to this small set of users, and then we're moving to the next cluster, A3, which is the larger set of users. So that's definitely a rolling deployment across the x-axis. But then we have this y-axis here, the traffic coming down, and how it's a little bit different. It's not, it ties into this rolling deployment, but it's more aligned with a canary deployment. The first canary is actually A1. Now, if we thought about this from the discussion that we just had, then we may say, oh, the canary deployment is A2 and A3 because we have this router that's sort of splitting the traffic out between a small set and a larger set. That is correct. But we also have this Facebook employees group. They're kind of canaries too, right? Because we're going to roll to them first and test things out and say, hey, is this working good? Are you guys having any problems with these features? And actually, that's very important. A very important, what I want to say, like audience of users to choose from, because these guys, they're closer to us, right? They're actually in-house with us. Maybe they can go back to that DevOps team and say, hey, man, that deployment that you guys just did was not cool. It broke a lot of stuff. So let's see if we can fix this before we roll this out to other users. So maybe we have to iterate there, maybe we have to fix some things, and then we roll to this next cluster, cluster A2. So this is where our Canary deployment actually starts, like our official Canary deployment, for whatever the case is. But in this case, I mean, we don't see on this particular diagram a percentage like I was using in the demonstration earlier, but we do see, or what to me looks like a fixed set of Canary users. So just imagine that instead of having some sort of dial inside of our traffic controller, that it's fixed, that it's set, that always 10% of the traffic is going to go to this small set, and always 90% is going to go to everybody else. So that way we're not really adjusting it, but once we roll the deployment into that first cluster in combination with the split of traffic, we know for a fact that we're only going to affect a small number of users with this deployment. So that's really like where the rolling and the Canary deployment meet, and shake hands and kind of say, hey, we're doing this thing together, right? So our cluster A2 is really that's really like where the rubber meets the road as far as our public facing view of this new deployment. And then after we verify everything's working good in A2, we can roll things over into A3 and let everybody enjoy the new features or the updates, the patches, whatever it was that we deployed into that particular cluster. So yeah, this when I found this or came across this particular example, I was like, wow, this is a really cool way to show how these deployment methods can be combined. And I'm curious to know if you've come across any others. I would definitely be looking for examples of blue green combined with rolling. I know that that's a thing. And then also Canary as well. And the way that, all of these can be combined together. Because another thing to consider, I mean, we're looking at this from a very high level view of these clusters A1, A2, and A3. What we don't see from this particular diagram is how the deployments are happening within that cluster. So there might even be a blue-green type scenario in A2. For example, there's 1, 2, 3, 4, 5, 6. There's 8 compute cubes or blocks in this particular A2. We could stand up a whole nother A2 cluster, deploy to that one, make sure everything's good there, and then tear down A2 original, and now we're sending traffic to A2 prime, make sure that's good. And then we, continue on with A3. And maybe even within A3, we have multiple groups of blue-green clusters because, there's more compute there. So maybe we have to do it that way. So that could be another way that blue-green comes into play in this particular deployment. Okay, I probably said enough about this guy. So let's move on to the homework. I'm not going to keep you long for this session at all, but I am sharing with you this assignment. The QR code is correct this time, or rather the link is correct this time. No typos. It should work for you. Also, the QR code there should work as well. And what this will do is take you to a repository with links to these particular items. Number one is the Canary release article that we took the image from for that previous slide. It's the article by Danilo Santos from ThoughtWorks. Now, you will read this article or take a look at it, browse it, and I want you to look at the date. It's not current. It's not brand new. This is an approach that computer engineers and technologists have been using for quite some time. And he even references documents that show that this approach was used even previously and maybe just had a different name. I think one of the terms he used was a phased approach. So you may come across that term if somebody says, we're doing a phased deployment. Well, it's essentially a Canary deployment. So you just have to, kind of put those two and two together. And I also have included in this particular assignment some labs. The first one is the Cloud Run Canary Deployments Lab on Google Cloud Platform. And the second one is AWS Blue Green Labs. There's actually 2 of them, so I didn't link to one or the other of them on this particular slide. But they walk you through blue green deployments using ECS. And one of them, Containers from the Couch, those gentlemen do a really good job of breaking down the deployment and all the resources that are sort of involved with it. The application, the build process. I believe they build a container, they push it to ECR, which is Elastic Container Registry, and then that triggers the deployment using code pipeline, code deploy into a ECS cluster, which has a service, which has tasks. They just break it all down, right? So these are great opportunities to really just like hone your skills. It's one thing for us to come together and talk about the theory behind these deployment approaches, but it's a whole nother thing. Yes, I did say another, to actually put your hands on the keyboard and practice or put some of these principles into practice to actually hone your skills and develop your automation prowess. And I'm particularly keen to recommend the Google Cloud Run, or the Cloud Run Canary Lab, because it's another platform. We, and I say we, meaning like a lot of other authors at LinkedIn Learning, and even like people in the community, we really press on AWS, and AWS has a phenomenal product, right? It's a great cloud, but there are other clouds out there, and Google Cloud, they have a really great product as well. Cloud Run is really cool. So I encourage you, even if you don't have a GCP account, you can get one for free and experiment with it. But I just want you to read through the lab and look at the steps that they use, and some of the terminology and the technologies that they're using there to actually get this container image running on the service, and then to do the Canary deployment between the two or three container images that they have running there. And AWS, we all know AWS, so jump in, check out those labs too, but definitely put some skin in the game and at least browse through these labs to kind of get an idea of where they go, or just take 30 minutes, an hour, and actually fire up your GCP account and run through this Cloud Run lab to see how a Canary deployment actually works. So I believe that brings us to the end of this particular session. It does indeed. So we're going to get those slides out of there. And I just want to say thank you so much for joining me for this session of CI/CD Summer School. I really appreciate your time and attention. I hope you take a moment out of your week coming up to check out those labs. I think you'll be the better for it. And I'll look forward to seeing you next week for CI/CD Summer School. I didn't add it to the homework assignment, but you already know. Once you see the announcement for the next session come out, definitely register, sign up, and join me so we can talk about this in real time or in the replay. So with that, I just want to say thank you so much, and I'll see you again soon right here in CI/CD Summer School.